Okay, here's our last video for section 1.5. Like I said, it's a pretty short section. We won't have too much to talk about in this section. But this last thing we're going to talk about is a little important, as we're going to see it a lot in chapter 2 when we're talking about this thing called the normal distribution. But again, that's for chapter 2, so we won't get too much into it. We talk about quantitative variables. The types of graphs we can use for those guys are either, and the screen share tab is kind of blocking. There we go. Now I can actually highlight. We're looking at either histograms or line graphs. We're not going to focus too much on line graphs because I'm making the bold assumption, and I don't know if it's a good one, I hope it is, that maybe most of us have seen kind of a line graph before and know how to read one. So we're not going to do too much with that. What we are going to do a lot with is a histogram, though, because like I said, histograms we're going to be using a lot when we talk about the normal distribution in chapter 2. So histogram is a graph with rectangles. It's like the bar graph, but now it's the bar graph for a quantitative variable, right? And here's kind of where I was talking about earlier with the classes instead of just the data values. Classes in this case are going to represent intervals. So from 1 to 5, 5 to 10, 10 to 15, however you decide to interval up your quantitative variable data, those are going to be your classes. All right, and so the rectangles are representing those classes. The height of each of the rectangles is still representing the frequency, just like we talked about with the bar graph. And there are, oh, that's a typo. There are no there are no gaps between the rectangles because it's a continuous interval divided into those sub intervals called the classes. So we want to show that it's kind of like a continuation or a continuum, however you like to say that. Okay, and then a line graph, just to kind of make sure we're on the same page. A line graph uses dots to represent the frequency of each data value and then connects the dots with straight lines. Yep. So let's go ahead and make a histogram. The following data shows the ages of Academy Award-winning actors from 1985 to 2008. Create a frequency distribution for this data and use it to create a histogram. All right, so the first thing we have to do is make a frequency distribution. And in order to make a frequency distribution, we're going to need to know the classes or the data values, or in this case, the grouping of data values, which is our classes, which are our intervals in this case. So if we look at our data, maybe just eyeball it and see what the smallest number you can find is and what the biggest number you can find is. All right. The smallest value that I see is this 36 right here. And the biggest value that I see looks like it's this 62 right next to it. All right, so we're going from 36 to 62. We're going from the 30s to the 60s. So there's a lot of different ways you can kind of make the intervals. And sometimes with a histogram, we're calling the intervals bins. So the bins will be our categories here. Sometimes you'll be told like how many bins to use, and that'll give you an idea of how to, separate the data based on those number of bins. But in this case, we're not really told how many bins we should use. So what we can do is just kind of, come up with our own bins. The only thing is that if you want to make sure you're showing everything, fairly, our bins usually have to be the same width, right? So what we could do here is we could kind of bin this data up by tens. We could do it by fives as well, but let's just do tens. If you want to try it by 5, go ahead. But we'll do tens. So from 20 to 29. And these include these numbers. So I'm including if I do have a 20, and if I do have a 29, I'm including those numbers. So and because of that, I start my next one at 30 because I don't want to run into the issue of, oh, do I put 29 in this one or do I put it in this one? We just make them clearly separate. To 39. And then here we'll have 40 to 49, 50 to 59. And then 60, we can just say 60 onward. So we can say we can kind of do this bigger than, greater than 60. So here are our classes, our intervals. And so now we need to make the frequency. So classes or bins frequency. So pretty much counting how many of these numbers fall into these bins. So how many numbers are between 20 and 29 inclusive, 30 to 39 inclusive, etc. So between 20 and 29, if you count them up real quick, it looks like we actually only have the 29. Yes, so that's just a 1. From 30 to 39, I kind of have this written out already, so I kind of cheated a little bit again, but if you want to count them out, go ahead. We have 8 in our 30 to 39 section, 9 in our 40 to 49 section, 4 in our 50 to 59 section, and 2 in our 60 and beyond section. So here's kind of how we create our histogram. We're going to, as we have, make our little vertical axis. Sorry, that's really ugly. And then go this way. That's also kind of ugly. And I'm going to scroll up a little bit. We just need our chart there to help us. So there's a lot of different ways you can do the horizontal axis. Let's do our vertical first. We know we're only going up to 10. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And then our horizontal axis, what we're going to do is we're going to go based off of these. Now you'll see lots of different things. You'll see just the midpoint being used. So I find the midpoint between 20 and 29. I'll see it labeled as 20 to 29, 30 to 39, etc. Another way you can see it is they'll go ahead and take off the horizontal axis and then use the beginning of each of these bins as the ticks. So we'll start at 0 to 20, 30, 40, 50, 60, right? And we have 1, 2, 3, 4, 5 bins. So we have to make sure we have, I guess we shouldn't start it at. So we'll just not use this. And whenever you have a break, usually signify it, like if you're going to break your axes, like you're not starting right off the bat at like a very sequential number, then you would do that by doing a little, not squiggle, a little kind of, I guess a squiggle. I don't know the technical term for this, but you would do this to signify, hey, I'm starting at a different number and then I'm scaling it different based off of that. Okay. So then we just, we do our thing. Here is our 20 to 30 section. We only had 1 person in there. So that's as tall as it goes. In our 30 to 39 section, we had 8. So we're going all the way up here. And remember, these bars are going to be touching. They're going to be neighbors, very close neighbors. 40 to 50, that's going to be up to 9. 50 to 60, that's going to be 4. Right about there. And then we had 2 in this category. Okay, so there's our histogram. And it kind of meets all the criteria we described above. It's kind of like a bar graph, except all the bars are touching. There's a lot of different ways we can kind of categorize our histograms, or we can describe our histogram shape. This looks pretty decently symmetric, not crazy symmetric, but it's kind of, it's close enough to being symmetric. So we call this symmetric because it looks kind of like kind of like that, right? Whatever's happening on one side is happening in the opposite direction on the other side. Some other shapes we can use to describe our normal distributions. Sorry, I don't know why I said normal distribution. Our histograms, sorry. I'm just gonna draw crude little histograms. I'm on a roll, sorry. we could see something like this. Okay, where this histogram is kind of tapering off a little bit on the left-hand side. We call this skewed left. Skewed left or left skewed also is another way to say it, or yeah, another way to say it. And the reason why is because it has a little tail on the left. There's a tapering off at the left, and what is important about that is that there's outliers, right? So the height of the bar represents the frequency, meaning that there's a lot of data over here, and very little data on the left-hand side, which means that there's outliers that are going to pull or that are going to want to affect the mass of data over here on the right. And then we have the other scenario where there's a lot of data on the right. Um, and then there's like a tail. You could even have like gaps and have little pieces of data over here. That would be skewed right or right skewed. Okay. And that, like I said, that's going to be really important when we get into the normal distribution, as I was randomly saying a few seconds ago, when we get into the normal distribution in chapter 2. Okay. I'll see you in the next section's videos.